Hi everyone, and welcome to this chapter of Dart Crash Course. In this chapter, we're going to talk about errors and exceptions. Now, errors and exceptions are very similar to each other, but there's one big distinction between them, and that is exceptions are meant to be caught, whereas errors are not meant to be caught. So an exception is something that you as a programmer cannot plan for, such as, for instance, getting data from a user and passing it to a class that does something, and then that class cannot accept, for instance, that value. However, an error is when something is clearly documented and a parameter to a function, for instance, is clearly documented as being acceptable from values, for instance, 0 to 100, but then you pass the value of 3000 to it. Then that would be an error because it's a programmer error that caused that problem, basically. So just know that distinction between exceptions and errors and try not to catch your errors. That's pretty much the only thing you really need to know as the biggest distinction between these two. But we're going to drill more down into the differences between exceptions and errors in this chapter. So without further ado, let's just get started. I'm going to go and bring up our terminal. It's something that we usually do. Let's go here and let's see. I'll bring terminal here and let's create a Dart application. So we say Dart create with a template of console, and we say exceptions and errors. So, and then we don't have any external packages in here. So let's just say code exceptions and errors. And we can get rid of our terminal. Let's go in here and say JSON workspace settings, and we say zoom level of 6. You don't have to do this as usual. This is just something for me as an instructor to do. And then we delete the main file that was created inside a bin folder, and we say example1 main function like usual, and then fswatch as well. fswatch, and we say this should run example1. Let's get rid of our explorer and also the terminal so we can get started with the first example. So in this first example, we're going to have a look at throwing an exception inside a constructor of a class. Okay, so let's create a class. We say class person, and we say final int age. So we have an integer age, and then let's make this a required named parameter. Now what we're going to do inside this person constructor is to have a look at this age, and if the age is less than 0, then we're going to throw an exception. So let's say if age is less than 0, then we say throw, let's do it like this actually, throw exception. Okay, and we say age must be positive. All right, and in Dart, you can actually throw anything. You can just say throw 1, or you can say throw hello. But it is common, it is like convention to throw an instance of exception. Okay, so it's just something that we've learned to do, but you can throw anything else. You can just throw the string itself, and the caller can catch it as well without problem. Okay, however, you can also have other rules in here. Let's just say else if age is more than 140, then you can say throw age must be less than 140. Okay, so this is these are two examples. One throws an exception, the other one throws a string. Then we can go and create a function that does a test of instantiation of this class. So we say void try creating person, and we pass an age to it. So we say by default is 0 in here. Let's make this this kind of parameter so we can actually pass a default value for it. Then at the call site, when you try to create instances of this person, you can wrap your code create or the instantiation inside a try and catch block. So if a code that you're trying to execute is known to throw an exception, and usually these types of codes are documented, so someone goes and writes documentation on top of this constructor and says, if you pass a value less than 0, then you get this exception. If you pass a value more than 140, then you get this exception. Okay, so in here we go and say we try to do something, and then we say catch any exception. Okay, and this E in here you can see is just an object. So we say in here print person with an age of a given age, and then we print that person's age just like that. All right, and then we catch in here, and then we say print get the object's runtime type, and then we print the exception itself. All right, very simple. So let's go ahead and try calling this function with some values, some valid values and some invalid values. So if we run our application now, you can see the first time we call that function, we passed 20, and that was just the age. So nothing happened. We didn't get an exception. All right. Actually, we can print perhaps a little separator in here. Let's print a separator. Let's say print this, so we can see the difference between the various execution of this function. So the first time we called the function with the value of 20 for age, nothing happened. We just created a person with the age of 20 and then printed that person's age out to the console. The next time around, we call this function with the value of -1, and -1 goes in this branch of code with the age less than 0, and then we get an exception. And you can see it says the runtime type is an exception, and when we print the object itself, it says exception, age must be positive. And that's exactly what we did in here, right? And then if we pass the value of 141, which is outside the positive range of age, we also get this exception that says its type is a string and its value is age must be less than 140. Okay, so just a takeaway from this section or this example is that you can throw anything in Dart, and you can also use try and catch in order to catch exceptions from code that actually throw them. All right, so let's go to example 2. Let's say example 2 Dart. And of course, we're going to create our main function in here, and then let's go to fswatch and say example 2. Then we get rid of our terminal. Okay. Now in this example, we're going to have a look at custom exception classes. So even though you can throw exceptions, but it's sometimes a good idea to, if you see that you're throwing a specific type of exception a lot of times, like invalid age, and maybe you're doing it in like 20 different places, it's a good idea usually to go ahead and create a custom exception class. All right, that basically, for instance, can prepare the message for you, or it has some special properties, okay, that you can use in various places inside your application when you're catching your exception, or maybe even when you're throwing your exception. So what we're going to do is to create a custom class, which is similar. I mean, our example in example 2 is going to be very similar to example 1, in that we're going to work with this person class and like different exceptions that are thrown inside a constructor, but we're going to create a specific exception in here. So let's call it invalid age exception, okay? And we say implements exception. So this is how you would go about creating a custom exception, all right? So let's say then we take the age in, all right, like this, and then in here we also need some sort of a message. So the caller to this class should provide a message for us saying that, oh, this given age is more than like that, which is not an acceptable value. So some sort of a message. So we say string message like this. And then if you go into the exception class itself, if I can get rid of this, there we go. You can see you can pass a message to the factory constructor as well. Okay. So, and this is similar to what we have in here. So let's create a constructor for our class that gives it age and message. And then we will overwrite the toString function in here. Let's make it an arrow function like this. Let's see, like that and like that. All right, so in here we say invalid age exception, and then we say just $message, and we say $age. All right, very simple. Then we go ahead into our person class. So I'm just going to go to example 1 and grab the person class from here like this, so we don't have to rewrite it. Then let's go in here and then have a look at what we've done so far. So we say if age is less than 0, throw invalid age exception, and the age is this age, and then the message is going to be age cannot be negative. All right, and in here we'll do something similar. We say throw invalid age exception, and the age is this age, and the message is going to be age cannot be greater than 140. All right, and a comma to get the formatting working as well. Good. So now that we have that, we can go ahead and create our little function that we had from before. I think it's called try creating person or something, this one. So let's just copy this and bring it to example 2 as well, right under the main function. And then in here, instead of just doing catch, we'll catch specific exceptions. And this is the format for catching specific exceptions. So we say invalid age exception, catch the exception. And in here, then your E will be an invalid age exception because you're constraining your catch clause to exceptions of this type. Okay, so in here also, what we're going to have a look at is not printing only the error or the exception. So let's just print the exception in here, but you can also add a second parameter in here called stack trace. Okay, and you can actually call it ST if you want to, but if you get ST in here, it will be your stack trace. So by adding a second parameter to your catch statement, Dart completely understands or automatically understands that this second parameter is your stack trace. Okay, and a stack trace is like the unwinding of the stack right before the exception happened, or at the point that the exception happened. So you can actually have a look at the function that caused this and also various other functions that made a call to this function right before the exception occurred. Okay, and let's print the stack trace as well. Okay, we have that. Now we can go ahead and basically do pretty much the same thing that we did in example 1 and call this function with various values. Okay, so let's have a look at the results. Raw receive, and I think we got invalid. There we go. So that's the second run. So the first run, it told us that the, let's see, print string, who's printing that one? Let's see, print string. Let me clear the console and then we run our application again. And then we have a look here. Okay, so now we're getting the value of 20 in the first execution of this function because 20 is a valid age. So we just print it to the console. On the next example, and we pass the value of -1, and then we get this invalid age exception, and it says age cannot be negative, you see. And also then we get the stack trace. So you see this is the most recent function, which is the call to a constructor of person. And then the function that called it is this try creating person. And the function that called this is the main function. So that's what the stack trace does. And in the third run of this function, then we're passing the value 141 for age, which is also not valid. It's outside the positive range or an acceptable range. And then we get the invalid age exception again. So what you need to take away from this example is how you can have custom exceptions and how you can catch those custom exceptions. All right. So let's close example 2 and let's go to example 3, Dart in here. Okay. And in this example, we're going to have a look at a keyword in Dart, which is called rethrow. Okay. So what I'm going to do is I'm going to bring the code that we had from the previous chapter, from the previous example, put the main function also in here. We forgot about that. Let's go to FSWatch and say example 3. And we go and bring the code like we had for person and we had for invalid age exception. All right. And we also are going to go and take the code for try creating person like this. Okay. And then let's go to example 3 and paste that in here. And this time around, what we're going to do is inside this on invalid age exception, what we're going to do is to say, wait a minute, this function is just going to try creating a person. But if an exception of type invalid age exception happens, this function isn't going to be able to handle it. It's just going to say, well, I got this exception. Whoever calls me has to handle it. Okay. So what you could do is to say, okay, if an invalid age exception occurs, then you use this keyword rethrow. Okay, what this really says that if any function calls me and an exception of type invalid age exception happens, I'm just going to rethrow it back to the caller. Okay, and in here you can say catch any other exception and then do something about those exceptions. But in the specific case of invalid age exception, and that might happen within the try statement, then I can't handle it. I'm just going to rethrow it back to my caller. Okay, so you can mix this statement with other catch statements. So let's go in here and then we say, okay, then within our main function, knowing that this try creating person will rethrow invalid age exceptions back at us, then we will wrap our code within try and we say catch error and stack trace like this. And then we'll go ahead and we say, okay, start trying. We say try creating person with the age of 20. All right. Then we say, okay, let me see, actually, I'm going to get rid of this one. Okay. So now we have pretty much the same example as before. We create persons with an age of 20, -1 and 141. Only this one's valid. And this one is the first invalid case of calling this function because it's got the age that is less than 0. And then in here, we'll just print the error. We say print error. and let's print the stack trace. So what's important also to note is that as soon as this try and catch block of code encounters its first exception, it will go to the catch block and it won't run the rest of the code within the try statement. So this is going to throw an exception back at us, right? Because it has the rethrow. And then right after that, try will say, oops, I've caught an exception. Then it goes to the catch block, and then this entire block of code is done. So this code will not be executed. All right, let's have a look at the results. There we go. So we first get the value of 20, and then we get an invalid age exception for -1, and then the try and catch block is completely done. So we don't go here. Okay. So good, that was an example of using rethrow. So anywhere inside your code, if you see that your function cannot, your try and catch statements cannot handle a specific exception, you can specifically mark it as rethrow so that the caller of your function will understand that, wait, you cannot handle this type of exception. So I have to do it, okay? And of course in here you can say on invalid age exception, you can basically handle it like this as well, okay? Specifically saying that I'm only handling this one, nothing else. All right, so that's for example 3. Let's go to example 4.dart, okay? And in this example, what we're gonna have a look at is the use of the finally block. So within try and catch, we also have another clause to that block, which is called finally. But first, let's create our main function. Let's go to example 4, fswatch, like that, all right? So in order to get how finally works, let's go ahead and create a little helper class, and we call it database. Okay, so it's just like a fictitious database. And in here we have a private property called isDBOpen, and by default we have the value of false. Then we create a function, we say future void, and we call this function open, like this. So you have to open the database first before starting to use it. And then what we'll do, we'll just create a future and we delay it by 1 second. And after that future is done, we say the DB is now open. All right. And then we say print database opened, like this. All right. So that's really our function. Just simple as that. Opening, it opens the database in 1 second and doesn't do anything else. All right. Then we go ahead and create a fictitious function. In here we say future string get data. So what this guy is going to do, it says if the database is not open, throw a database not open exception. And what we're going to do then is to create an instance, and we're going to create a subclass of exception and call it database not open exception. So let's say class extends, implements exception. All right. And then we just have a toString method in here that says database not open exception. All right, that's it. So if database not open, we throw, and then you don't have to have an else in here, to be honest with you, because as soon as your code throws, then it's not going to continue. But some people prefer to write else. So if this, do that, else do something else. But some people just prefer not to write the else at all. And then they say, okay, if that didn't happen, then the code is definitely going to go to line number 17. But if the database wasn't open, line number 15 is going to completely stop the execution of the program at this point and is not going to go to line 17. So it's up to you if you want to have an else or not. Okay. So let's say future delayed. And then in here we say a duration, let's say duration of seconds, 1. And in here, then we say our future returns some data, just like that. All right. Boom. Good. Now that we have that, let's go ahead and create another fictitious function in here that's called close. So we say future void close, which is supposed to close the database. And all it does is just marks the isDBOpen property as false. All right. Good. Now that we have these, we can go ahead and start testing this out. So within the main function, let's just say try, and then we say, like right before it, we said final DB is equal to database. And inside try, what we're going to do is to say await DB.open. And let's mark our main function as async as well. Here, async. Then we add a catch, we say on database and not open exception. Then we say print, we forgot to open the database like this. All right. And then we say, we just leave it like that. All right. So instead of doing this db.open, we actually simulate a case where we forgot to open the database before we call getData. All right. So we already know that getData is going to throw the database not open exception because we forgot to open the database before. Okay. So let me run the code and see what happens. You see, it says we forgot to open the database. Okay. So what we could do is to have a look at some at the finally block that I wanted to mention in here. So what we're going to do is to say, okay, even though sometimes we may do this correctly, like let's say that someone had done this. Okay. Now, if someone had done this, the code is completely fine and the database is open. And then you'd say, okay, let me just await then after this database close. All right. And you can see database is opened, and then what happened? Database open, okay, and the next, there we go, database close, okay. So this code looks like fine. It's fine to us. It says first open, then get the data, and then close it. And if this happens, then do this. What happens though if someone goes ahead and does this? Then what could happen is that the constructor of this class maybe did something that needs to be cleaned up after. But we're completely forgetting to do that because this line of code is going to throw this exception, meaning the line number 5 will never be executed. So we're never cleaning up the database and we're not never closing like the database. Maybe this created some sort of a database cursor, which we basically forgot, or we couldn't have the chance to even clean up after because db.close never got executed in line number 5 simply because getData threw an exception which stopped the execution of the program right after line number 4. Well, the answer to this is the finally clause. So every try and catch block can have a little block called finally, which is always executed right after the try block or the catches block. So this finally block is guaranteed to be executed right after try and catch are done doing their work. Okay, and in here you can say await db.close. So we're ensuring that the database is always closed right after this try statement, and then you can remove line number 5 from there. Okay, there we go. It says we forgot to open the database, and then it says database closed. So even though an exception was thrown, we're still going to our finally block. Okay, so that was example number 4 with finally. Let's go to example 5. And then we stop the execution of fswatch, and in here we say example 5, like that, and a main function like we usually do. Let's get rid of the terminal as well. Now, in Dart, you can also have this type of funky way of basically annotating your functions. And you may have seen this actually, we haven't really done any annotations inside the Dart crash course in this playlist. So it may be the first time that you're seeing this. So without me trying to explain it too much, let me just tell you first simply what it's going to do. You can in Dart annotate a function with a class. And what we're going to do in this example is to tell Dart that a specific function throws specific exceptions. So whoever calls this function can immediately see that it throws specific exceptions, and they can even like command and click or control click in Linux and Windows on those particular exceptions to go to their source codes. So instead of documenting them, and documentation is just plain text, so you can't actually click on them to go to specific classes, we're going to annotate those. And this is what this example is all about. So let's get started with that. We're gonna start this example by creating a class. We call it throws. It doesn't necessarily have to be called throws, but we just say we throw something. It's a generic class. Also, there is a video in this playlist about generics. I think it's right before this video actually. So if you haven't watched that video, please go ahead and do that because we talked very, very much about generics in that video. So what we're gonna do in here, we're gonna say this guy throws something. And then we say final list of that something is the exceptions that we throw. Okay, so it's just a class with a generic list of something. Okay, nothing specific really. Then we create 2 exception classes. All right, and one of them is called dog is too old exception. The other one is called dog is too tired exception, or dog is tired exception. Okay, so the goal of this is so that we're gonna create an animal class. Let's say class animal, and then we give it an age. So we say age and a constructor for that. Okay, let's make it a required named parameter like this. And then we go ahead and say void run like this. And by default, we say throw unimplemented error. Okay, so this is an error and it is not meant to be caught. So this is the first time our application or any of our examples is throwing an error. And as I mentioned in the beginning of this chapter, errors are not meant to be caught. Errors are programmer errors. So it's an error that is caused by our fault. So nowhere in your code should you try to actually catch an error. Okay, so what we're saying in here is that we have a void run function that we haven't actually implemented. Whoever tries to extend our class has to implement this function. Okay, so let's just say, okay, now we want to actually tell the developer who calls this function that our function throws an unimplemented error. So you can just go ahead and say throws, just the name of the class that we created, and then pass this in here. So you say unimplemented error. Okay, call to a const constructor. Okay, that's fine. Let's go in here. Let's say throws. Okay, unimplemented error, throws. Let's see what we actually missed in here, throws. And this one has to be a const constructor. Sorry about that. So you can see now we've annotated our void function in here, void run, and we said by default it throws this error. And this really doesn't do anything except for it being a decorative and an annotation, right? So this in itself isn't doing anything, but it just tells the developer that this function throws. Now, in this example, you'd be thinking, well, it is very simply visible that this function throws this, but in real life, you can have a function that is maybe 30 lines of code. And at the last line, or maybe the next to last line, it's gonna throw an exception. In that case, it's going to be a little bit more difficult to find it within the code that this function is actually throwing. Therefore, annotating it with this is going to be really helpful. So let's go now and create a subclass of this animal. We say dog, all right, and we say it extends animal. And then let's give dog a Boolean property. We say final bool is tired, like this, and a constructor for dog. And also we need to say, well, let's say this is a const constructor, and then we make this a required named parameter. And also let's say required super.age. All right, so that we get the value for super as well, like this. Good. All right, and it says that we're not calling a const constructor, so we need to go into our animal and say this is also a const. All right. There, oops, there we go. So now we have dog that's got a property that says is tired. Now, let's go ahead and override this run function from our animal class in here. So let's go here and say we're overriding the run function like this. And I think actually in Visual Studio Code, you can just type run and it will understand that you want to override. There we go. Yeah, you could do this as well. So let's go ahead and say if age is more than 10, all right, then we say, then say throw const dog is too old exception. So if your dog's more than 10, it probably doesn't want to run. Okay, it's just an assumption we're making. Else if is tired, then we say throw const dog is tired exception. Okay, otherwise we say print dog is running. Okay, so now that we have this, you can see this override in itself is an annotation. So you can see it's an annotation, and we can go ahead in here and say our run function throws like this, and we say dog is too old exception and dog is tired exception. Okay, so you can actually annotate your overwritten functions as well. So in this class, in the animal class, we said run throws unimplemented error, but in the overwritten version of that function inside the dog class, we say it doesn't throw that error anymore. It throws dog is too old exception or dog is tired exception. Okay, so what we can do then is to go ahead and try this out. So in the main function, let's also make sure that our fswatch is running. Let's say print hello. Oops, hello, like that. Yep, it's running. So let's create a try and catch block. So we say we try, and then we say catch any exception, and we just print that exception to the console. And then we create a dog. We say print dog aged 11 is going to run. So this is going to be our first example, going to run. And ... in here. And let's say dog with age of 11 and is tired is false. Then we say make that dog run. Okay, then you can see in the console, we say instance of dog is too old exception. So we made a dog that is too old run, and that dog can't do that according to our according to our rules. All right, then let's copy this code from here, and then we paste it in here, and then we say dog, a dog. Let's say a dog or a tired dog is going to run. Okay, like this. And then we say age is perhaps 2, so it's just like a puppy. And then we say it is tired indeed. So make that dog run. What happens? Then we get an instance of dog is tired exception. All right. So what you learned from this example is that you can create your custom annotations, and then you annotate your functions to tell the developer who's calling your functions that, hey, this class throws these exceptions. And of course, you could go ahead and say, I'm going to document this function throws the following exceptions like this. All right. And this documentation is also good. And no one says that you shouldn't document your code, but what is actually a little bit difficult about this is, for instance, if you have an editor, if you have a simple text editor and you go and change the name of this class, then your editor may not be able to change all instances of that class within the documentation. I'm not sure how Visual Studio Code is going to react. So let me just say 222, and I can see it changed it in the documentation as well. So that's really good, but your code editor may not be able to do that. So one of the good things about this is that, well, it will basically work in any code editor that has refactoring features, that if you change this instance, it will also change it within the annotation. Sorry, if you change the name of this class, it will also change it within the annotation, which also allows you to be able to click on it and go to the class that implements it. But I believe in Visual Studio Code, you can also click in documentation. So let's try that. Here we go. Click, and you end up here. So it's not that important perhaps in Visual Studio Code to do that. All right. So, and also please take away from this example that although you can annotate your functions like this, but please also do write documentations when you're throwing exceptions. So the caller to your functions or classes know exactly what to expect. We're done with example 5. Let's go to example 6, Dart, and a main function in here. And let's stop FSWatch for example 5 and run it for example 6. Okay. Now, what we're going to talk about now is errors. We've talked about exceptions, but we haven't really talked about errors except for unimplemented error. And I mentioned that errors are programmer errors. Okay, so an error should never really be caught. If you see yourself doing try and catch around errors, then you should stop yourself, because errors are not meant to be caught. And if you find that the code that you're calling is causing an error, you need to try to fix that instead of trying and catching it. Okay, so let's see an example of that. Let's say class person, like this, and then we say int. We have a private property age, and then we say int get age refers to this age property in here. And then let's go and create a constructor. So we say person, and then we take a required int age property in here, and we set the private age property to that incoming age. All right, so that's our constructor. We have a getter for that private property, and then we'll create a setter for it as well. So we say set age, like this, int value, and then we say if value is less than 0, then this is an argument error. Okay, this is a built-in error that you can throw, and we say age cannot be negative. All right, so this is a contract. I mean, the developer should know that the age of a person cannot be negative. So if you call this, if you set the age to a negative value, you should perhaps expect some sort of an error. Okay, it's called an argument error, and you can use it in your code as well. So it's nothing that we created, basically. All right, so now that we have that, we can go and say final person. We create an instance of person with the age of 10, and then we say print this person, and let's see what we get to the console. We just get instance of person. Perhaps we could overwrite the toString on this person. So I'm just going to bring that code over. Let's bring it here. So we just say person with the age of 10. All right. Then what we're going to do is to change this age to 0. So we say person that age is 0, and then we print the person. All right. And you can see it says age is 0. That's fine. Then you go ahead and create a try and catch block in here. All right, like this. And then we will say finally. Let me get rid of the terminal so we can see the code in its entirety as well. Then let's say person age is -1, like this. And then we will try to print this person. All right. In the case of an exception, we just print the exception. And in the final, we're just going to say print person again to see if our changes were affecting this person or not. So first we get 10, 0, and then we get an exception that says invalid arguments, age cannot be negative. And you can see the age wasn't actually changed to a negative value because right here the code threw an exception or an error, and then we jumped into the catch and then the finally block. So the person's age stayed at 0. So what we need to learn from this example is that, well, exceptions and errors exist. They can be tried and caught. However, please do not try and catch an error. Exceptions, you can do that, but do not catch errors. Errors are meant to be there to discourage you from doing what you're doing. And if you see this code, well, the solution is simple. Just don't do it. Don't assign the value to -1 when you know that it is not an accepted value. So let's put a little bit of a comment in here. So to discourage us from doing code like this, just to be very explicit, this is just for demonstration purposes, just so you can see you can catch an error, but you should not do that. All right. Let's close example 6 and we go to example 7. And we'll go to our FS watch as well and run it for example 7 in here. Good. And the main function, really good. So in this particular example, we're gonna have a look at capturing stack trace for exceptions. We've already seen this before, so I won't dive too deep into it. So let's just create a simple exception called dog is tired exception. Poor doggy is tired. Okay. Then we will create a class called dog, which we've already done before. You can see it has a property called is tired. And when you call the run function on it, we say if you're tired, then we throw this exception. All right. Then let's go ahead and say in the main function, we say dog is tired false. Then we make this dog run. All right. And that's going to be fine because it just says doggo is running. All right. But then we say try and we say dog is tired true. And we make this guy run. And then in here, inside the catch block, you can either decide to only catch the exception, or you could also try to catch a stack trace. And if you add a second parameter to your catch block within the parentheses, then that parameter is always going to be your stack trace. So stack trace like this, and we print the stack trace as well. All right, there we go. Now it says we got an exception, instance of dog is tired. The function that actually threw it was called dog run. The function that called that function is the main function. And then here's the entry point to our entire Dart application, to the isolate, I believe. That is basically our main isolate for our application. And don't worry about isolates. We're going to have a separate chapter about them. So there we go. Now we have, we've learned also how to use stack traces. And sometimes they're useful actually. And some code, for instance, some libraries like Crashlytics, will allow you to see your stack traces even on the web. So they will be reported to Firebase and they'll be visible for you as a programmer to have a look at later. Okay, so they're quite a powerful tool. I really hope that you enjoyed this chapter as well and hope to see you in the next one.